All right, welcome to the part of the video where I do some homework problems because I love math. Also, to, give you a little bit of help, a little something to look at if you ever get stuck. So, again, hopefully you should know where the homework problems are. You just go to the right section, 2.1 in this case. Again, I'm a little cropped right now. You just scroll all the way to the bottom. Or if you want to go faster, you can just Control F1 dot space. All right, sometimes that works. Here we are. Oh, there's a space. All right, Control F1 space dot, one space dot, or whatever homework problem you want to do. There's a space between the dots, and they actually added that space. My other book does that. I didn't know this one did. They actually add that space to make it a little easier for you to navigate there. So you don't have that other issue that I was going to have. So we're going to start by looking at problem number 4. So in this exercise, there are points P and Q on a graph, and P is the point 1, 1. Q is some arbitrary point x comma y. And they're on the graph of f of x equals x cubed. So this is kind of you kind of have to parse this information and see what does it actually mean. You can't even answer the question unless you kind of know what it's talking about. So we're looking at a cubic function right here. So it's going to look something like this. Whoops, a little crooked. We're looking at a cubic function. One of those toolkit functions. Should be familiar with the shape at least. And one of our points is always at 1, 2. Oh, wait. I accidentally... Oh, no, not this again. One of the points is at 1, 1. Just maybe right here. And the other point is going to be at x comma y. And these are our x values down here. The other points are very close to 1. And we're going to look at secant lines. So it wants us to complete this table with just a bunch of values. All right. X, y, the point, and the slope of the secant line. Okay, right? X is x, y is y. The point is q. The point at x comma y. And m secant is the slope of that secant line. X, y, the point q, and the slope of that secant line. And all you have to do for this problem, is fill in this table. And again, our function is f of x equals x cubed. And so the x values are already given to you. Like so. So again, kind of thinking about what we're talking about, we're looking at the slope of the secant line in this part. These x points, these x values are getting closer and closer to 1. Our secant line is getting closer and closer to our tangent line here. So we should expect some patterns. All right, so we're going to kind of see if that actually happens. So if x cubed, if this is our x, what's our y? We can use a calculator. Again, a lot of different ways of using a calculator here. But our function now is f of x equals x cubed. So again, you could just type in what is f of 1.1, or for better calculator practice, you could look at what is 1.1 cubed. So that's the y value here, 1.331. So what's the point? The point is just x comma y. What's the slope of the secant line? We're going to have to use a formula. Let's find all the y values first. Since we're here, 1.01, add a 0 here. We're going to get about 1.030. Wait, this tells us actually how many significant figures it wants us to use, doesn't it? It wants 8 significant figures. Oh man, my table's not big enough. All right, sorry, graph. All right, nice try, Jason. Glad that you're starting to read instructions. All right, so we're going to need more space for this. 8 significant figures. Remember significant figures. And if you don't really remember significant figures, you can just Google it. There's a lot of good explanations. But basically, it's numbers that mean something. All right, so I think this may give us enough space. So the first one, I believe, was exact. The second one, actually, Desmos may or may not round for us. I think Desmos gives us, yeah, I think Desmos gives us pretty good rounding. Yeah, all right, we have more digits. So this is what it is exactly, 1.030301 for this one. And again, the point, Q of xy, and the slope of the secant line. This is the point 1.1, comma 1.331. This is the point 1.01, comma 1.030301. Then that is 1, 2, 3, 4, 5, 6, 7 significant figures. The next one, just add another 0 here. 1.003003001001. But it only wanted 8. So 1, 2, 3, 4, 5, 6, 7, 8. It's going to be 7 decimal places in this case. Include the 0, that's important. That's going to be 1.001, comma 1.003. Oh. Great. And one more. 1.000 1.0003 00. Let me count how many we need. 0 is how you round here. Because there's a 3 after this, but it only wanted 8. All right, so 1.0001, 1.0003, 000. You can see the pattern. It's a little tedious, which is why I did not assign all of these. That would take too long. But look at the patterns. When you're doing a homework assignment, whenever possible, try to figure out like what is the problem there for? It's not there to make you waste time. It's there to teach you, to reinforce knowledge. So look what's happening. As we're getting closer to 1, right? X is getting closer to 1. You can think, right? This is X approaching 1. What's Y doing? Well, Y is also approaching 1, right? In a specific pattern too, which is kind of interesting, right? It's basically 0s and 3s. 1 0 means 1 0, 2 zeros means 2 zeros, and so on. Look at the patterns. It'll make things more interesting. All right, and then let's look at the slope of the secant. So for that, again, we'll just use a calculator. So it's just going to be the slope of the secant, remember, is the difference in y values divided by the difference in x values. So in the first one, right, going to be 1.1 cubed minus 1 cubed divided by 1.1 minus 1. Okay, that's 3.31 is the slope of our secant line here. The next one, we just add a 0 right here and right here. 3.0301. Look at the pattern. The next one, just add another 0. 3.003001. And the last one that my head's going to cover. Here I have a solution. There we go. That's a perfect size for teaching. Let's add one more 0, shall we? So I actually kind of like this. This works out pretty nice. 3.00030001, but we have the same thing from before. Significant figures. 0003 0 0. We want 8 sig figs. That's going to be 7 decimals in this place. All right. So, all right, maybe I can be maybe I can be a little bit bigger. Maybe this is a little silly. So these are the slopes. So as x is approaching 1, y is also approaching 1. How is our secant, the slope of our secant line, behaving? Well, it kind of looks like it's approaching 3. All right, let's look at this. All right, this basically just means if we're looking at a cubic function, and here, let me get let's get our x and y axis like more normalized. As we're looking at a cubic function and getting really close to the point 1, 1, our notes, our secant lines, have implied that the slope of this function right here is about 3. Okay. We'll find out later that it is indeed 3. But that's what these problems are getting you to look at. It's a lot of tedium, a lot of plugging things in, but if you use Desmos or something, you can go through it really quick. I was explaining it, and so I went slower, but you can go through these really quick. Shouldn't be that tedious, but think of the concepts. Think of what you're doing. Look at what those x's are doing. Look at what those y's are doing, and then look at what that secant line is doing as well. The slope of that secant line is approaching 3 here. Later on, we'll say something like the derivative of this function is always 3 times x squared. The derivative is the slope, so if x equals 1, the slope is 3 times 1 squared to 3. That's what we'll do later. Okay? Later on this quarter, that's what we have to look forward to. A little bit faster to do it this way. Okay? Let's do number 5 on the homework. These all come in like in little sets. All right, so looking at number 5, it says use the values from the right column to guess the value of, oh, I spoiled it. Guess the value of the slope of the tangent line at x equals 1. Well, the slopes of the secant lines, I'm not going to write this down. I'm going to say it verbally. The slopes of the secant lines are approaching the slope of the tangent line. So the slopes of the secant lines are approaching 3. So the slope of the tangent line is, we're guessing, is 3. 6 is good. Use the value in the preceding exercise to find the equation of the tangent line at that point and graph it. All right, I need to make a note of this. Hopefully you already have the note on this. Can just graph with Desmos. I'll make a note. Hopefully you already see that. But for number 6, let's skip straight to 6. How do you find the equation of the tangent line? We haven't talked about that. We're going to use something called point slope form. There's a bunch of different forms that you can use, but point slope form is the best in this case. And that's y minus y naught equals m times x minus x naught. And all you need to use this formula, you only need 2 things. You need a point and you need a slope. We are not very creative as mathematicians. So we need a point for this line, but it tells you our point, right? It says the tangent line at point P. What was our point P? The point P was 1, 1. So that's our point. And what's our slope? Well, the slope of the tangent line, we haven't talked about it too much. That's going to be the limit of those slopes of the secant lines. This right here. Duh! If I could duck down if I had a green screen. Darn you, October. Knocking down my green screen. It's 3. Is that number right there behind my head? Behind my office wall. All right. And our slope is 3. So this is all we need to use this formula. This is our x naught. This is our y naught. And that's our slope. So it's y minus y naught equals m times x minus x naught. And it doesn't tell us what form it wants the line in, right? It just wants an equation of the tangent line. This form is fine. You could rewrite it if you wanted. You could distribute, add a 1, get 3x minus 2 if you wanted it in slope-intercept form, but you don't need it in slope-intercept form. This is perfectly fine on top. And it wants you to graph it, so let's graph it on Desmos. We'll graph y minus y naught equals m times x minus, ooh, look at that. So blue is our function, x cubed, white is our tangent line. Notice that it just skips off the function, kinda. It barely touches, just skimming the edge. This is going to be really important later on in this quarter, okay? The slope of this tangent line is the slope of the function. Has to do with the derivative. Has to do with all sorts of goodies that we're going to get to later, but I'm getting on a... Sometimes I get too excited about math and I talk about it forever. Let's do the other examples. Let's look at 18 real quick. Compute the average velocity of the stone over these intervals. Oh, we actually basically did this exact same thing in the last video. I'm not going to do this again. Again, just plug in these values for t and use that average velocity, that V bar formula from video 2.1.3. And then guess the instantaneous velocity, just like we did in the other ones. Again, as these average velocities are secant lines. Notice that this interval is getting smaller and smaller. So with every calculation, you should be getting closer to that instantaneous velocity, that slope of the tangent line. All right. But it's basically just going to be calculations. If you need a refresher on 18 and 19, go back into the previous video, 2.1.3. Okay. And that's it for me. Again, if you do have more questions, you can always ask. I do like talking about math. So have a great day and good luck.